Hi, hello everyone. This is Dr. Chiranjeevi Manike, Professor and Head of Data Science and Cybersecurity Department, MLR Institute of Technology, Hyderabad. As part of data mining video lecture series, in this lecture we are going to discuss another classification method, that is k-nearest neighbor classifier, that is in short KNN. So here we are going to see when this k-nearest neighbor was introduced, proposed, and here we are going to discuss the procedure to find out the k nearest neighbors, that is to identify. Suppose if you do not know the class label, or if you have an unknown sample, then we are going to discuss how that sample class label would be decided based on this k nearest neighbor. So this k nearest neighbor was described in the 1950s, and here we will get one question mainly because, like, even machine learning or because it's a part of a machine learning, KNN classification is a part of machine learning. So all these methods or the algorithms were proposed long back around 1950s and 1960s. Why the importance is more, the demand for all these algorithms like machine learning algorithms and deep learning algorithms more nowadays? Though I discussed in the very beginning lecture, I would like to recall it again. So why the demand for these technologies like machine learning or deep learning, AI, artificial intelligence, though these are all the subfields, why the demand is more nowadays, not earlier, that is, though these are introduced in 1950s. So because there are three main reasons. One reason I would like to recall it again, that is the availability of data. So earlier we do not have enough data. So because all these deep learning models or the machine learnings, these are all based on the past experience, or we teach the models by supplying the historical data. So we do not have the huge amount of historical data. So that is the reason these machine learning, deep learning, and artificial intelligence technologies are becoming more and more popular nowadays, because the data generation is rapidly, the different types of data, the huge volumes of data being generated rapidly nowadays. So this k nearest neighbor classifier is labor intensive when given the large training sets, and did not gain the popularity until the 1960s, when increased computing power became available. That is another reason. Earlier we do not have the much computing power, or though it is available, it's more costly. So that is another reason. And one more reason I would also like to reveal, that is the storage cost. Storage cost and the data availability. Data availability, storage cost, and computing power, cost of computing power. So these are the three reasons. So now that's why these three technologies are becoming more and more popular. So we have enough data, more than required data. Like we are posting, we are tweeting in Twitters, we are uploading the videos in YouTubes, and we are writing the reviews on the products, etc. They're all the different forms of the data, the tons of the data available now. So there's no problem with the data, and then the storage cost also drastically reduced. So next, the computing power also. We have the high performance computers are available, and even we can like a commodity hardwares can also, by using the commodity hardware, we can make the high performance computing machines. So that is, the computing power is becoming cheaper, and the storage cost also becoming cheaper, and the data availability is more, the more data is available. So that's why. So it has since been widely used in the area of pattern recognition. K nearest neighbor mainly used in a pattern recognition. So nearest neighbor classifier is based on learning by analogy. that is by comparing a given test tuple with the training tuples that are similar to it. So we are going to compare the test tuples and the training tuples that are similar to it. So tuple means the set of like suppose X is a tuple, so it is a n-dimensional vector like x1, x2 and so on xn. It's an n-dimensional vector. Like if you take a data set and it would have n number of tuples and also the attributes also. So the values of the attributes x1, x2, x3 and so on xn are nothing but values of attributes a1, a2 and so on, some let us say am. So in this nearest neighbor classifiers, so it compares, it learns how it is going to learn. It compares the test tuples with the training tuples that are similar to each other. So the training tuples are described by n attributes. So these are the n attributes. Each tuple represents a point in the n-dimensional space. So in this way, all the training tuples are stored in an n-dimensional pattern space. So when given an unknown tuple, that is we don't know the class label of that. So a k-nearest neighbor classifier KNN searches the pattern space for the k training tuples that are closest to the unknown tuple. There are k number of training tuples. We will search for the k number of training tuples. Those are very closest to the unknown tuple. So these k training tuples, those are closest to the unknown tuple, are the k nearest neighbors of the unknown tuple. So closeness is defined in terms of a distance metric such as Euclidean distance or any other distance measures would be used. Sometimes, like suppose the data points like x1 and x1 y1 is a one data point, x2 y2 is another data point. The distance would be measured by using a different distance functions. Let us say if you take a Euclidean distance function, the distance between these 2 points would be calculated as x1 minus y1 whole square plus x2 minus y2 whole square. So x2 plus x2 minus y2 whole square. This is one that is Euclidean distance, and we would also calculate, like sometimes we also use the distance method just simply, that is x1 minus y1, we'll take the modulus values, and x2 minus y2, like this. This is also another measure we can use. There are many other distance measures. So Euclidean distance between the 2 points or the tuples, let us say x1, x2 and so on, x1, 2 and so on, x1n, and another tuple that is 2, 1, 2, 2, x2, 2, x2 and so on, x2n would be calculated. This is the same, whatever I just this formula that would be generalized for the n number of attributes. The distance would be calculated. Like suppose if x1, capital X1 and x2 are the 2 tuples in the data set, and by using this Euclidean distance, that is the square root of sigma is equal to 1 to n x1i minus x2i whole square. This is a simple method. So here the unknown tuple is assigned the most common class, its k nearest neighbors. So what we did so far, so we identified n number of training tuples, that those are matching with the unknown tuple. So then the most common class among its k nearest neighbors. These n training tuples are nothing but the k nearest neighbors. We would say k nearest neighbors. So here for example, you can take this one, like if you plot the values on this 2-dimensional space x1 and x2 tuples, and here you can see, and this is a red color a circle represents an unknown tuple. We don't know the class label of that, but we know the remaining. There are two classes, like the A class A, that is yellow color represents, and the another color B represents another class. So here the K is the how many number of nearest neighbors. So for example, if you take a K equal to 3, so there are 3, we have to take the 3 nearest neighbors. So then if K equal to 6 nearest neighbors, if you want to take the opinion of 6 nearest neighbors, and here the K equal to 6, then, and you can see, and there are 4 number of here the 4 tuples belongs to the one class, and the 2 tuples are belongs to the another class. So this is the way we find out the class label, or we assign the class label that is based on the most common class among its k nearest neighbors. So let us take this example here. Now, so from this diagram, we can easily understand that there are 3 different classes. This is one class, and this is another class, and this is another class. And there is a data point which is unknown sample. This is unknown. This is a unknown sample. So we have to find out the class label of this unknown sample by using this one of the classification, that is KNN, k nearest neighbor. So we have to calculate the distance. Like suppose, let us say that is K includes all the attributes, all the tuples in this class. So here, then we have to find out the distance. So the distance would be calculated, like suppose there are 2 green color circles, and the distance to the each one, like suppose here the 2.1 and 2.4 is the distance to the first green and the second green. Those are also called as nearest neighbors, because these are close compared to the remaining other data tuples in this diagram here. Similarly, we would also calculate but here, and these are all, like suppose here 2 plus 5, 3, 5 plus 3, 8 data points, 8 data points in this. And if you want to find out this, the 4 nearest neighbors, then we select the first 4, which the data points which are near in the sense similar to the unknown tuple. So here there are 2 green, that is the first nearest neighbor is a green the color tuple, or the second also green, and next. These are the 4 nearest neighbors, and their corresponding distance is also 2.1, 2.4, 2.4, 3.1 and 4.5. So now the majority, we have to count the majority, that is to decide the majority number of training tuples in this 4 nearest neighbors. The majority number of training tuples belongs to what is the class of that majority tuples. So here from this we can easily understand that, like suppose this is the 4 nearest neighbor, the k equal to 4. So from this we can easily understand there are 2 data points or training tuples which are belongs to the same class, that means the same color, green color. So then we can assign the class label of this unknown sample, that is the point. So that is, we could say like the predicted class label of this unknown sample is a class label of this green color circle. So what is the class label? Let us say the green color is A and B and C. These are the class labels. So then we would predict, based on this k nearest neighbor classifier, we would predict the class label of this as A, because there are 2 nearest neighbors, or the 2 training tuples which are very close to this unknown tuple, and those class label is A. So the k nearest neighbor classifier can also be used for the various like mainly the numeric predictions. So that is to return a real valued prediction for a given unknown tuples. So in this case, the classifier returns the average value of the real valued labels associated with the k nearest neighbors of the unknown tuples. But how can the distance be computed for attributes that are not numeric? Like suppose the categorical variables, then how the distance would be calculated? So such as for example color, there are like in the previous example, in this case there are three colors. So how, like suppose if it is not a like a nominal values, and if it is categorical values, so then how the distance would be applied? So in that case we will give the colors, like suppose the number, in this case like number of tuples belongs to the same color, the count would be considered to calculate the distance. Then another thing is what about the missing values? So because as I said many times, and we also discussed how to deal the missing values, if a data set has a missing values, because we have to understand the influence of missing values on the classifier also. So how we are going to deal this missing values, that is another important concept while to understand this k nearest neighbor classifiers. Next, how we can determine a good value for the k. As we we randomly pick the k value k, that is 4 or a 6 or 3 somewhere else like that. But how and which is the best value, or which is what is the method we need to follow, or is there any method, or is there any formula to find out the best k value, that is the number of nearest neighbors? So there is no search, but only based on the error rate. Error rate means how it is deviating from the actual values. So there are different, we will discuss the different measures to find the error rate. But here the error is, let us just only for understanding, the error is the deviation, the difference between the actual value and the predicted values. So here we randomly start from the k value, or we can start from the minimum k value. Then we'll find out the error rate, and we'll keep on increasing the k value. Then if you plot these values, the correlation between the k value and the corresponding error rate. Suppose if the k equal to 25, that is number of nearest neighbors at 25, sorry 2.5, then what is the error rate? Similarly, we'll take just a significant number. So then if you could plot these values, then we will be able to find out a value where is very low error rate, that is the k value where the error rate is very low. So we have to select the k value accordingly. So in this case you can see here, that is first the very small value of k, and the error rate is like this, and after this, and it moved up, and then it fall down to this 0.46 error rate, and it's continuously dropping, and it reached this point that is approximately close to 0.44, and it's moved up, and it's little bit moved up, and it's continuously moving up in the reverse direction. So that we can take this point as the best. That means the error rate is very small, where the k equal to, what is the k value? The k value would be in between the k 7.5 and 10. So this is the way we can select the best, we can determine a good value for the k. So nearest neighbor classifiers use the distance based comparisons that intrinsically assign the equal weight to the each attributes. So they therefore can suffer from the poor accuracy when given a noisy or irrelevant attributes. Because of this reason, this k nearest neighbor classifiers use the distance based comparisons, that is to assign the equal weights to the each attributes. So if the data has data set is a noisy data, or if whatever the attributes we have in a data set are the irrelevant, so that affect the performance of this k nearest neighbor. So then it would not be recommendable to use the k nearest neighbor classifier if the data data set is noisy or if it has irrelevant features. So these k nearest neighbor classifiers can be extremely slow when classifying the test tuples. So other techniques are also used to speed up the classification time, that includes mainly the partial distance calculations and editing the stored tuples. So this is the way we can apply this k nearest neighbor. Here mainly the k nearest neighbor KNN is mainly used for classification. It is also a supervised approach, and here the main objective lies here is selecting the best k value, that is by using the different techniques. In this we discussed the elbow method. That means we'll take the k values from the low value to the maximum values, and we will also find out the error rate. So we select the k value for which the error rate is very low, and it is mainly this k nearest neighbor cannot be recommended to the data sets if the data set has the noisy or the attributes are irrelevant. So thank you for watching this video.